This video is going to review the use of Sig Figs. This is going to be a major point in AP, and you always need to make sure to use these. Be sure to use Sig Figs whenever you're recording measurements. If you're giving a number, make sure that it has the proper number of Sig Figs. And anytime you're doing calculations, make sure to record your answer in the correct number of Sig Figs. When recording measurements with significant digits, you always want to add one estimated digit to the measurement past the graduations on your device. Look at the ruler on the left. The object above it, it is between 1.3 and 1.4. Since the actual graduations or measurements on our ruler are to the tenths place, we want to add a hundredths place. It is closer to 1.4 than 1.3, so we can say that this has a measurement of 1.38 centimeters. Always include a unit in your measurements as well. Look at the graduated cylinder on the right. You can even look at the zoomed in part. Remember, whenever you're reading graduated cylinders, you always want to look at the meniscus, which is the lowest part of the curve. The individual marks on the graduated cylinder are measurements of 1 milliliter. The meniscus, the lowest part, is relatively close to 43, but we want to say that it's pretty much on the money. So it would be recorded to 43.0 milliliters. And yet again, always record a measurement when looking at your devices. When you're recording measurements, Sig Figs will tell others about what type of device you use to measure. If you include a hundredths place, that means that your graduated cylinder had markers for a tenths place. Here we have two graduated cylinders. We want to know which graduated cylinder was used to record the measurement, including Sig Figs, of 4.7 milliliters. Since we have a 0.7, that means that we added that tenths place, so our graduated cylinder only measured to the ones place. The graduated cylinder on the left measures to the ones place. Graduated cylinder on the right has individual markings for the tenths place. So we use the graduated cylinder on the left when recording our measurement. If we had used the graduated cylinder on the right, we would have added an additional hundredths place to show that our graduated cylinder already had a tenths place, and we estimated that next digit. Take a moment to record the following measurements using Sig Figs and proper units. Feel free to pause the video if needed. Pay attention to the graduated cylinder on the left. The liquid line is between 40 and 50. And since there are 10 markings from 40 to 50, those are marking ones places. So remember to add a tenths place whenever you're measuring. The meniscus is near 45, but is slightly below 45. So we could say that that measurement is 44.8 milliliters. Look at the thermometer in the middle. The liquid line is between 20 and 25. There are individual ones places marked with all the graduations, so yet again we need to add a tenths place. This is fairly close to 23, but is slightly above 23, so your measurement should be somewhere close to 23.2 degrees Celsius. Look at the image on the right. This is from a burette, which we'll use in titrations and some other experiments. I want you to make sure to pay attention to the scale. On burettes, you're letting liquid out of the bottom, so the measurements as the liquid level goes down is actually increasing the number of milliliters that were used. Here the meniscus is right at 20. It's pretty much on 20 on the dot. But there are 10 markings between 20 and 19 or 20 and 21. So each individual graduation is measuring a tenths place. So you need to make sure to add an estimated hundredths place. So we could say that this is 20.00 milliliters. All right, so here we're going to review how to count sig figs when given a number. To do this, remember we use the Atlantic Pacific rules. So if you picture the United States, the Atlantic is on the right side, the Pacific Ocean is on the left side. Whenever you have a number, say 0.0047, in this number there is a decimal present. There is actually a printed decimal point. That means that we are going to start on the Pacific side of the number, so on the left of the number, and once we hit the first non-zero digit, we count every digit until the end, going from left to right. The first non-zero digit from the left is 4. So if you count the 4 and the 7, this number has 2 sig figs. Say that we have a number like 1,250. This does not have a printed decimal point, so our decimal is absent. Therefore, we're going to start on the Atlantic side. So we are going to read this number from right to left when counting sig figs. The first digit from the right that is not 0 is 5. So you count every digit afterwards. So this will have 3 sig figs. You want to make sure that as soon as you start counting, you count every digit until the end of the number. Some of those ending zeros and beginning zeros will not count, but any zeros after you started counting are included in your number of sig figs. Let's practice. We're going to take a minute to practice counting sig figs. In the number 0.0067, there is a printed decimal point, so we would start on the Pacific on the left side of the number, and the first non-zero digit is going to be 6. So both the 6 and 7 are significant figures, so this number would have 2 sig figs. In the number 0.00670, it's the same number as the first one, but now it has an additional 0. It still has a printed decimal place, so we're still going to start on the Pacific side on the left side. The first non-zero digit is yet again the 6, but now 6, 7, and 0 count. So this number would actually have 3 sig figs. Look at the number 12,200. There is not a printed decimal point, so the decimal is absent, so we're going to start on the Atlantic side, on the right side of the number. The first non-zero digit from the right is 2, so the 2, and the 1 count. So this number also has 3 sig figs. Look at 0.0105. There is a printed decimal point, so we're going to start on the Pacific on the left side of the number. The first non-zero digit is 1, so the 1, the 0, and the 5 count to give this number 3 sig figs. Look at 1.5. This yet again has a printed decimal point, so we start on the Pacific on the left side of the number. The first non-zero digit is the 1, so the 1, the 0, and the 5 count to give this number 3 sig figs. Look at 20.80. This yet again has a printed decimal point, so we start on the Pacific side on the left side of the number. The first non-zero digit from the left is 2, so all 4 digits are going to count. Look at 430. This does not have a printed decimal point, so we are going to start on the Atlantic on the right side of the number. The first non-zero digit from the right is 3, so both 3 and 4 count to give this 2 sig figs. But look at this number. It yet again is 430, but this number has a printed decimal point, meaning that instead of starting on the right, we start on the left of the number. The very first non-zero digit from the left is 4, so all 3 digits count. This is an instance where your number rounds to the tens place, but you need it to show that this actually has 3 sig figs instead of 2. So you add that decimal point to make sure that people know that 0 does count. I want us to look at our rules for using Sig Figs in calculations. We have two different rules, and our first one is anytime we are multiplying or dividing. When multiplying or dividing, our answer should have as many sig figs as the measurement with the least total number of sig figs. So our answer cannot have more digits than our original two numbers. Take these for example. If we do 3.887 times 15.5, punch it in your calculator as is, and the calculator gives you an answer of 60.2485. Now you have to look at your sig figs. 3.887 has 4 digits. 15.5 has 3 digits. So our answer can only have 3 sig figs due to the 15.5. So our actual answer would be 60.2. Our second rule for using calculations and sig figs is going to be used whenever we're adding and subtracting. Our answer should have as many decimal places as the measurement with the least number of decimal places. So multiplying and dividing looked at the least number of digits, while adding and subtracting looks at the least number of decimal places. Let's look at a couple of examples. We have 4.49 plus 8.3. If you put that in the calculator, you get 12.79. Now, our two numbers we used, 4.49 has 2 decimal places, while 8.3 only has 1 decimal place. So our answer can only have 1 decimal place. So we need to round this to the 10th place, and we will get an answer of 12.8. Look at our second example. We have 4.80 minus 3.966. When you put this in the calculator, you get 0.834. 4.8 has 2 decimal places, while 3.966 has 3 decimal places. So we would need to go with the 2 decimal places. So our answer would be 0.83. One thing that tends to confuse people is using scientific notation in Sig Figs. For numbers written in scientific notation, all the numbers given in the coefficient are going to be used for your significant digits. So you can ignore the times 10 and whatever power is there. So for the number 3.080 times 10 to the 5th, we are only going to look at the 3.080. It has a printed decimal point, so we're going to start on the left. So this would have 4 sig figs. Scientific notation can often be used to show the difference between significant and non-significant zeros. Say that you have 1,000,000 and you need to write it in sig figs. The only way to do that to a certain number of sig figs is to use scientific notation. So here we have 1,200,000 and we want to write it using 3 sig figs. So our 3 sig figs would be the 1, the 2, and that first 0 from the left. So we need to round it to that first 0. So remember, your coefficient in scientific notation can only have 1 digit before the decimal. So that would be 1.20, and we move the decimal 6 times, so it would be times 10 to the 6th. If you're still having trouble with any of this, check out the Math Skills Review link on our Symbaloo page.